So let's try one more example, and now we are just playing again. We already got the core idea. We know how it is going to work. Start with the rightmost region. It is always positive, and just keep playing with it as long as you get that basic factorized form. So now once again the challenge is factorization. So let's just start playing with it. So let's start with that. Can I take a negative out just to make my process easier and the expression look more like what I'm used to? So x square minus 3x minus 4, and let this be the same as less than equal to 0. Now I have to factorize this, and once again this should not be too much of a challenge. I think most people will be able to come up with x minus 4 into x plus 1. Quick revision, this is a product, this is a sum. You are looking for two numbers whose product is minus 4. So you could have a 2 and a minus 2, or you could have a 1 into a minus 4, or minus 1 into a 4, or this doesn't make too much of a difference which one do you call negative, right? So you play with this for a couple of seconds and you will come up with this in case this was troublesome, but hopefully this should be an easy step. Now the moment I get this and I have a negative sign outside, right, less than equal to 0, why don't I multiply both sides by a simple minus 1? So minus 1 multiplied on this side will remove the negative sign. 0 into a minus 1, no problem, 0 will remain 0 only. But remember, you have an inequality and you're multiplying both sides by a negative number. Whenever that happens, you're supposed to change the sign of the polarity. That's why I was calling it sign of the polarity. Change the sign of the polarity, right? So go back to the basic videos, how to work with inequalities. If you are multiplying both sides by a negative number, the sign should change. Now once again it is very easy. My roots are minus 1, my roots are 4. I want positive. I know beyond 4 it is going to be positive, so x is greater than 4. It wants equal, so I can throw in an equal also. And anything less than minus 1, so x is less than minus 1 will also give me the overall positive, and again equal to minus 1 is also fine, right? So another example of how factorization form or factorized form is needed for the shortcut to work, and that's why the importance of your basic day 0, day 1 operations. So let's again just notice step by step escalation in the story. Let's play with this expression, x minus 3 whole square into x minus 2 into x plus 2. So very quickly maybe and very easily plot the roots. The root is going to be minus 2, 2 and 3. And remember what we were doing, we were trying to analyze the polarity, whether it is positive or whether it is negative. And if I forget the square for a second, I can build the usual story very easily. I know this region is going to be positive, this negative, this positive and this negative again. But there is a square here, and let's think about what that means. If I go for a number greater than 3, say if I put a 5 here, 5 minus 3 positive, positive square positive. But even if I go for a number less than 3, if I put 2 here, 2 minus 3 minus 1, minus 1 whole square still positive. That means this expression is going to be positive no matter what. That means this is not going to impact the story, because remember I am interested in the interplay of positive and negative to finally reach the whether it's positive, the whole expression is positive or negative, right? So think about this for a second. This is always going to be positive, so you can just forget it from the story except the equal part. We'll come to that in a second. But as far as polarity is concerned, this is not adding anything to the story because this is always positive. So for a second forget this and your story changes slightly. Anything greater than 2 on the right, because now 2 is your maximum root, it will always be positive. And again check for a second. If I go for 2.5, this is positive anyway, positive into positive, positive. This would have been a negative, 2.5 minus 3 minus half, but there is a square, so overall result will become positive. Because normally if you had made your situation, you would have said minus 2, 2 and 3, and above 2 it was going to be negative, but because of the square the story is changing. Above 2 itself it is always going to be positive. And why is that happening? Because this expression will always be positive. So above 2 is positive. Now your story can work like the usual. The alternate regions are going to be so. So let's pay again some attention to the problem statement. It said greater than equal to 0. That means greater than 0, x is greater than 2. Again, greater than 0 I want positive, that means x is less than minus 2 is also fine for me. I want equal to 0 as well, so even this will do, equal to 0, because 2 will make it equal to 0, minus 2 will also make it equal to 0, equal to 0 is acceptable, so that is also fine. But now I have to pay attention to this point, because this did not make any difference on positive or negative, but this can still become 0. If you put x is equal to 3, this will become 0 and the overall expression will become 0. So that is also fine. That means x equal to 3 will also work. Though this x equal to 3 is taken care of in this part of the story, but in case it was not, maybe what if I put a x minus 1 whole square, right, just for fun, forget the 3 story. So everything will still be the same, you will work out the same logic, but this time there is a 1 in the middle, because your answer will say x is less than equal to minus 2, x is greater than equal to 2, but there is a 1 hiding somewhere in the middle which you have not considered in your polarity, but it will make it equal to 0. So then in that case you will add x is equal to 1 is another part of the story. Why this twist, last minute twist in the story? Because when it was 3, it was anyway on the right side of 2. So you will say, yeah, it's already taken care of. My job is to point out what are the possible error areas as such, right? So I hope this story is also making sense to you. And if this number, putting up the number is throwing you off, very good, hit pause, think about it, again draw out the story, you will see anything beyond 2 is positive, between 2 and 2 is negative, and beyond minus 2 is still positive, because this expression is still out of contention. Then the only point was when it becomes equal to 0, that's how I cover it. So same story, minor twist again, I've thrown in a cube here. And again, if you hit pause and maybe just observe for yourself and think about polarity, whether it's positive or negative only, you're not looking for value, you're only looking for ranges, right? So once again you will see, if this is a positive, once again you will see that this cube is not making too much of a difference. Why? Because if this number is positive, a positive cube will give you a positive. If this number is negative, a negative cube will give you a negative. So this, whether this cube is put here or not put here, so whether this cube is put here or not put here doesn't make too much of a difference, right? So that means for all practical purposes, our story is still the same. Roots are minus 2, 2 and 5. I will not even ignore it this time because it is important. And then my regions will follow. Greater than 5 will be positive, between 2 and 5 will be negative, alternate region positive, and then again negative. I want greater than equal to 0, let's say. So I know x is greater than 5 and equal to 5 will also do. Everything is identical as previous problems, right? And greater than 0, x is greater than minus 2 and less than 2, this region, but equal to will also be absolutely fine for me. Right? So what is the quick summary? That if any of the expressions have a power which is odd, right, it doesn't make a difference at all in our polarity analysis. If any of them have a power which is even, then you can just ignore it from the process except for considering the equal to 0 point. Right? So when you are analyzing it or learning for the first time, it might seem like too much. But then one day later, maybe summarize everything, run through all the examples again, and you will see it's very limited idea, and most of it is common sense. You will begin to see, yeah, of course, if I have to make it 0, then what happens? If I don't want to make it equal to 0, then what happens? So best not to memorize, first best to understand, and then practice a lot so that this becomes second nature. Say if such a story is given to us, there is no 0 on the other side. Is it challenging? No, not really. Just move the 3 to the other side. So what will you get? You will get a x plus 4 upon x plus 1 and a minus 3. This is greater than equal to 0. Now think of this 3 as a 3 by 1 and add or whatever, subtract these together. What will you get? You will get a x plus 1 in the denominator and an x plus 4 from this fraction. 1 into x plus 1 gives you x plus 1. So 3 into x plus 1, and there is a minus in between. So minus 3x and a minus 3. And again, just throw the symbol here, greater than equal to 0. Simplify this. I hope you have done that, or rewind maybe, and you will get a 1 minus 2x greater than equal to 0. Again, You are not happy with this because you want everything in the x minus a form. So just multiply this expression by a minus 1 and this side also by a minus 1. But because you are multiplying by a minus 1, your signs are going to change. The 0 will remain a 0 only, but a minus 1 into a 1 will become a minus 1, and a minus 1 into a minus 2x will become a plus 2x. So this expression will become a 2x minus 1. And where will this part and where will this become 0? 2x minus 1 equal to 0. So x is equal to half. So the only difference between previous examples and this one is that the root is coming at not a perfect integer, it is coming at a fraction. Get comfortable with that idea as well. So all you have to do is, if you're confused, you have to say, okay, when is this equal to 0? X is equal to half, that is going to be a root. And now I can apply my shortcut theory. Forget the, keep the symbol less than 0 on the side. One of my roots is minus 1 and the other is 1 by 2. Start with the regions. Right of 1 by 2 is going to be positive, in between negative, left of minus 1 positive. What do you want? You want less than 0. So you want this as the answer. So you want x is greater than minus 1 and x is less than half is what you want. And since there is no equal sign at all, you don't have to worry about it. When is this problematic? Minus 1 if I put here, I'll get a 0. But minus 1 is not being considered at all. So this story will be fine for me, right? So very basic level operation, but something that if you're already good at your basic equation work, there is nothing new here. The new part was this understanding, the regional understanding that on one side you have positive, then negative, then positive, etc. And after that, your basic factorization work mostly. So that's it. I'm going to stop right now. You have enough in your arsenal now to try out the exercise by yourself. Most of the ideas are already covered here. You now just have to apply them over and over again. That means you have enough, you know enough to now start trying out any problem to do with inequality, and I mean any kind of, at our level as such, right? So I'll stop for now. Try out the exercise by yourself, and then after only trying it out severely, join the next discussion on the exercise discussion. This is it for now. I will see you soon.